Hello guys, welcome to agriculture tutorials. Today I am going to discuss about remote sensing. Remote sensing is the science and art of collecting information of about an object, area, or phenomena without direct physical contact by detecting and analyzing electromagnetic radiation reflected or emitted from the earth's surface. Simple definition for exams: remote sensing is the acquisition of information about the Earth surface using sensors mounted on satellites or aircrafts without physical touching the object. Example of remote sensing: measuring crop health using satellite images, mapping soil moisture using microwave sensors, estimating the forest cover from the space. Basic principles of remote sensing. Remote sensing works based on the interaction between electromagnetic radiation and earth features. Step by step principles of remote sensing is the energy source. The sun, natural source, emits electromagnetic radiation, or sensor itself emits energy. Active remote sensing. transmission Transmission through atmosphere. Electromagnetic radiation travels through the atmosphere. Some energy is scattered or absorbed by gases, dust, or water vapor. Interaction with the earth surface. When electromagnetic radiation reaches the earth, it may be reflected or absorbed or transmitted. Detection by sensor. Remote sensing detect by sensor and reflect or emit energy by capturing by a sensor. Data processing and interpretation. Recording the recording recorded signals are converted into images. Features are identified based on tone, texture, color, and pattern. Our images will be recorded by the signals of electromagnetic radiation that are converted into images. The features are identified based on tone, texture, and color and pattern. Interaction of electromagnetic radiation with earth surfaces. Nothing but reflection. Three key interactions: reflection, absorption, and transmission. Reflection is nothing but energy bouncing back. Example: green plants reflect strong in near infrared. Water bodies mostly absorbed energy, nothing but absorption, and the water bodies absorb most near infrared and short infrared waves, and the energy passes through transmission. The third one key interaction is transmission. The energy passes through clean water transmission, visible light. Important concept of spectral signature. Each object reflects electromagnetic radiation differently. This unique reflectance pattern is called spectral signature. Each object have a unique reflectance. Electromagnetic radiation differs together one and other. Used for distinguish crop, soil, water, forest, urban areas. Spectral signature is an important concept in remote sensing. Each object having different unique distinguished characters of spectral signature for crop, water, and forest and urban areas. Electromagnetic radiation is the energy that travels in the form of waves at the speed of light. Electromagnetic radiation is the energy that travels in the form of waves at the speed of light. Properties of electromagnetic radiation. Wavelength delta. Wavelength is denoted by delta, distance between two wave crusts, upper crust and lower crust, like that. Frequency is nothing but small f, denoted by number of waves per sound per second. Sorry, frequency is nothing but number of waves per second. Relationship is nothing but delta into f, means wavelength into frequency is equal to speed of light. The wavelength is equal to frequency, speed of light. Electromagnetic spectrum is the complete range of electromagnetic spectrum arranged according to wavelength. Important spectral regions used in remote sensing are ultraviolet rays, visible range rays, near infrared rays, and short wave infrared waves, and the thermal infrared waves and microwave region. These six regions are important for the remote sensing. Ultraviolet rays are bandwidth is 0.3 to 0.4 mm, nanometers, micrometers, mostly absorbed by the atmosphere, limited to remote sensing application. Ultraviolet are limited remote sensing applications range. Visible range is human eye sensitive region. This is visible range zero point 0.4 to zero point 0.7 micrometers. Zero point 0.4 to zero point 0.5 is blue color, zero point 0.5 to zero point 0.6 is green color, zero point 0.6 to zero point 0.7 is red color. The near infrared rays is 0.7 to 1.3. Vegetation reflect strongly here near infrared, and the best region for crop grow model and crop health biomass estimation is easily possible through near infrared rays, and the biomass estimation will be possible, and NDVI calculation is possible in near infrared. Short wave infrared is sensitive to moisture content. Thermal infrared is emitted thermal energy. You mainly thermal infrared range is 3 to 14 micrometers, and used for thermal infrared used for surface temperature, crop water stress, and evapotranspiration. Thermal infrared microwave region is 1 mm to 1 meter range, used in radar remote sensing. Penetrates microwave region penetrates through cloud, rain, and light vegetation. Microwave region suitable for all weather imaging. Types of remote sensing based on energy source. Passive remote sensing uses natural energy, sun. Example optical satellite imaginary, and the multispectral sensors. Active remote sensing is nothing but sensor emits its own energy. Example radar and LIDAR. Importance of remote sensing in agriculture. The importance of remote sensing in agriculture is nothing but crop area yield estimation, crop health monitoring, soil moisture and fertility mapping, drought and flood assessment, and precision farming decision support. These all areas remote sensing is important in agriculture. For one line exam purpose, very important thing is remote sensing definition: acquisition of information without physical contact or touch. Spectral signature, unique reflectance pattern of object. NIR region best for vegetative analysis. Thermal infrared measures surface temperature. Microwave works under cloudy conditions. Summary: overall, remote sensing is based on the interaction of electromagnetic radiation with the Earth features. Different regions of the electromagnetic spectrum provide specific information about vegetation, soil, water, atmosphere. Proper understanding of electromagnetic radiation and its behavior is essential for accurate interpretation of satellite data in agriculture and environmental studies. Thanking you everyone. Please like, share and subscribe to agriculture tutorials. Jai Hind. Jai Hind.